Hello everybody, welcome to my channel. Today we are going to discuss about Fourier series part 2, Dirichlet conditions, application of Fourier series, difference between Taylor and Fourier series, definition of periodic function, how to solve Fourier series of exponential function. Dirichlet condition, application of Fourier series, difference between Taylor and Fourier series, these all small definitions can come in 2 marks questions in your exam. So let's get started. Okay, now we will talk about Dirichlet conditions. What are basically Dirichlet conditions? Dirichlet conditions are very important for 2 marks questions in engineering maths examination. As defined, any function fx can be expressed as a Fourier series a naught by 2 plus summation n1 to infinity an cos nx plus summation n1 to infinity bn sin nx, where a naught, an, bn are constants provided. So what is the condition of fx so that it can be represented as Fourier series? Fx should be periodic function. What is periodic function? A function which repeats its value after a fixed time interval. It should be a single value function. If we put something into this function, then there will be a single value answer. It should be finite. Fx should be finite. Second, fx has a finite number of discontinuity in one period. If it has any discontinuity in one period, that should be finite. And fx has at most a finite number of maxima and minima. If fx has maxima and minima, that should be finite number. At most finite number, there should be only one maxima, there should be only one minima for that function. So what are the conditions for a function so that it can be expressed as a Fourier series? That fx should be periodic, single value and finite. Fx has a finite number of finite discontinuity in one period. Fx has at most a finite number of maxima and minima. One word that you should remember in Dirichlet conditions, that is finite. So now we will move to our next definition. Now we will learn about application of Fourier series, where exactly Fourier series is implied in real life. Actually, what is a Fourier series? Fourier series convert any periodic function into sine and cosine series. And sine and cosine series can be expressed as sine and cosine signals, and these signals will be used in different type of waves in experiments to change linear waves into sine cosine waves. We took any function and then we changed that function into sine and cosine series, and then that sine and cosine series will be used on graph as sine and cosine waves to compress picture. In physics, it is used partial differential equations. Number theory, this concept is used. Signal processing, this concept is used. Oceanography, this concept is used. Forensics, this concept is used. When we convert periodic function into series of sine and cosine, and that cosine and cosine series will be used as sine and cosine signal waves, and this type of signal waves are used in different type of machines, different type of signal processing. So this is mainly a use of Fourier series. Now, what is difference between Taylor series and Fourier series? Fourier series is focused on expanding a periodic function in infinite sum of sines and cosines. On the other hand, Taylor series represents function as an infinite sum of terms of polynomials. So What is the logic of Fourier series? That will expand periodic function into infinite number sum of sines and cosine, and the Taylor series will represent function as infinite sum of terms or polynomials. What is the Taylor series formula? Summation as 0 to infinity fna x minus a power n upon n factorial. What is fna? That is nth derivative of fx at a. We just put here derivative of different type of terms and then their polynomial, and then we put n, that is 1 2 3, and then expand this series. So what is the basic difference? That Taylor series will expand the function into infinite sum of terms, but Fourier series will expand only periodic function into infinite sum of sines and cosines. Now, what is sine and phi? Sine and phi value is 0. These are some values that you should keep in your mind while solving your sums. Sine and pi is 0, sine 2 and pi is 0, cos and pi is minus 1 power n, cos 2 pi is minus 1 power 2, that is 1, cos 2 and pi, that is minus 1 2n. You know that 2n will be a even term, so minus 1 will be exactly 1. Cos n plus 1 pi, that is minus 1 n plus 1, cos n minus 1 pi, that is minus 1 n minus 1. Sin pi is 0, cos pi is minus 1, and these two formula will be used for solving exponential function as a Fourier series, that is eax sin bx dx integration, that is eax a square plus b square, same as it is in second formula. This function, this term will remain same. Then a sin bx minus b cos bx. In sin there will be a minus sign, in cos there will be a plus sign. So first we took a sin bx and then we took b cos bx. A cos bx plus b sin bx plus c. A sin bx minus b cos bx, a cos bx plus b sin bx plus c. These two formulas are very important, so you should learn these formulas. Now our second question is, obtain the Fourier series for fx is equal to e minus x in the interval 0x to 2 pi. Question 1 is already solved in Fourier series part 1 video. You can just check into my channel and find that video for question number 1. Now we are solving exponential function series in this video. So obtain the Fourier series for fx is equal to e power minus x in the interval 0 to 2 pi. Solution. Let fx is equal to e minus x is equal to a naught by 2 plus summation n 1 to infinity a n cos n x plus summation n 1 to infinity a n sin n x is equal to 1. What is the first step when we solve Fourier series? We assume our function is already a Fourier series. So we let our function is equal to a naught by 2 plus summation n 1 to infinity a n cos n x plus summation n 1 to infinity a n sin n x, and this is the first equation. Then this is the first step. Then what is the second step? We have to find a naught, a n, and bn. Here it should be bn. We have to find a naught, a n, and bn values, and then put those values in this series so that we can find a whole series for given exponential function. So by Euler's formula, a naught is equal to 1 upon pi 0 to 2 pi fx dx. This is the formula of a naught. We put e minus x dx. What is the integration of e minus x? That is, what is the integration of e minus x? That is e minus x upon minus 1. That is e minus x upon minus 1. When we integrate ex dx, that will be ex, and when we integrate e minus x, that will be ex, and derivative of minus x will be divided by it. Derivative of x will be divided by it. So that is e minus x upon minus 1, 0 to 2 pi. Then we put this value, and e0 will always 1. So minus 1 upon pi e minus 2 pi minus 1, e minus 2 pi upon pi we solve minus 1 pi with e minus 2 pi and then with 1, and then we took denominator same, or you can say we did LCM here, 1 minus e minus 2 pi upon pi. This is the answer of a naught. Then we will solve an, that is equal to 1 upon pi 0 to 2 pi fx cos nx dx, 1 upon pi 0 to 2 pi e minus x cos nx dx. We already discussed that the formula of EAX cos BX dx, that is equal to EAX upon A square plus B square, A cos BX plus B sin BX. Then we put that formula in this equation, 1 upon pi 0 to 2 pi e minus x cos nx dx. We put what is the value of, when we compare EAX with cos BX, what is the value of A? That is minus 1. What is the value of B? That is n. So we put those values in this formula, e minus x minus 1 whole square plus n square minus cos nx plus n sin nx 0 to 2 pi. Then we put those 2 pi and 0 values in this function. First we put 2 pi and then we put 0. You know that what is the value of cos 2n pi? That is minus 1 power 2n, and you know that 2n is even, so answer will be 1. So sine 2n pi, that value is 0. So it is n multiply 0, and minus 1 power 2n. Minus 1 power 2n will be 1. So only minus 1 here. And e minus 0, you know that e minus 0 or e 0, that is 1. Minus cos 0 plus n sin 0 and cos 0 sin 0, that is 0. Cos 0 is equal to 1. And sin 0 will be term 0 because n is multiplied by sin 0 and sin 0 is 0. Now we put these values here, and when we solve this whole term, we get 1 upon pi minus e minus 2 pi plus 1 upon 1 plus n square. We take positive term first, 1 minus e minus 2 pi upon 1 plus n square, 1 upon pi. This is the value of an. Now we will solve bn. Bn formula is 1 upon pi 0 to 2 pi fx sin nx dx, 1 upon pi 0 to 2 pi e minus x sin nx dx. We already discussed that integration of EAX sin bx dx, that is EAX upon a square plus b square, a sin bx minus b cos bx. Now we compare this function with this function, we get a is equal to minus 1 and b is equal to n. Ax compared with minus x, we get a is equal to minus 1, and bx is compared with nx, we get b is equal to n. Then we put these a and b values in this formula, and then we put 2 pi and 0. You know that sine 2n pi is 0, cos 2n pi is equal to minus 1 power n, and sine 0 is 0, cos 0 is 1. We put all these values here, and in the end we get 1 minus n e minus 2 pi upon pi 1 plus n square, and this is the value of bn. Now we will put a naught, an, bn values in equation 1. What was equation 1? That is fx is equal to e minus x, a naught plus summation n 1 to infinity an cos nx plus summation n 1 to infinity bn sin nx. We will put a naught value, an value and bn value here. Those terms which does not consist n, we kept aside of the summation here. And when we put n values from 1 to infinity, we will get this series, and when we put n1 to infinity in sin nx summation, we will get this series. Thank you.